Alright, in this video we're going to walk through the carbon cycle. Okay. In the water cycle, when we talked about the water cycle, water was moving between the biosphere, the hydrosphere, the geosphere, the atmosphere, but in every case, it was still water, right? It might have been a solid version of water, it could have been a gas form. Like the water vapor that's coming out of my mouth right now, or it could be a liquid form of water, right? Precipitation, or maybe it's in the lakes. All right, either way, water doesn't really change from any different molecules. It doesn't turn into any different molecules in the water cycle. This is not the case for carbon in the carbon cycle, and that's why some of this gets a little complicated, but I'll do my best to explain that. Okay, so we're going to start by, let's see. Okay. We're going to start with a tree. Okay, good old trees. We really need trees. They're underappreciated. Okay, that's a pretty good looking tree. And here's land. Now, in the atmosphere, we have carbon dioxide. Okay, there's the carbon. It is not a carbon dioxide is not the same as carbon. Carbon is an element, and when it is joined together with two oxygens, it forms carbon dioxide. Okay, we contribute to the pool of carbon dioxide through a process, but we'll get there. Okay, so when carbon dioxide is taken up by a tree, okay, it goes into their leaves, and it is able to make glucose to feed itself, because plants are incredibly cool. If you look at the chemical structure of glucose, it is 6 carbons, so C6. It's 12 hydrogens. Look at that, C, H, and O, 6 oxygens. Okay, what kind of macromolecule is that? You've got a C and an H and an O. This is a carbohydrate. Okay, look, OSE ending, it means it's a sugar. Okay, glucose is one of the simple sugars, and plants are able to make that through a process known as, let's see if we can make this happen, photosynthesis. I've tried to move this over and it's not working. So, bear with me. You know how to spell photosynthesis. Okay, so let's say that there is an apple on this tree. Okay, here's an apple. And Dr. Sharda gets hungry and she takes the apple. It's not the Garden of Eden, it's fine. Here's my mouth because I'm hungry. There's some eyes. Look at that. When I put this apple into my mouth and I take the glucose, right, the glucose and other macromolecules in here, this is a process known as assimilation. If I start here, might it work a little better? Assimilation. Oh yeah, look at that. Oh, of course now I can move it. Alright, so issues with technology. So the glucose molecules and all of the elements in there are going to be taken in. They're going to be digested in my gut. They're going to be divvied out to the different parts of my body that need them, and rearranged into other macromolecules and in general may be used as fuel. Okay, so in the mitochondria, glucose is actually converted into ATP, and I release in that process carbon dioxide as a byproduct, as a waste product, in fact. Okay. If you want to know some extra details about this, I actually need oxygen to go in my lungs as well. Okay, I use oxygen to burn this fuel, this glucose, and out comes carbon dioxide. Okay, so what is this process known as? This process is called, my cells are breathing, so cellular respiration. Okay, Alright, made it through 3. Alright, let's see what happens next. Let's say this tree, this beautiful tree, let's say it's 200 years old and it falls over dead one day. Okay, it happens, it's sad, but things die. Okay, boom. So now its roots are hanging out in the air, right? You have this big old stump and the branches, right? The leaves are gone because they're not photosynthesizing anymore. But you basically have a dead log. The dead log that used to be full of macromolecules with carbon in all of them, because all macromolecules have carbon because it's kind of like a backbone molecule. Okay? So you have, oh, what in the world? I'm not even going to deal with that because I don't know what happened there. Carbon as macromolecules. Okay? Now, over time, this log is going to sit here. The water is going to evaporate because these cells had a lot of water in them. Bugs are going to come in. Fungi are going to come in. Moss is going to come in. And it's going to start breaking down the tree. Okay? If that happens in a certain way, let's say it gets buried and it's kind of maybe even preserved a little bit, the nitrogen, the proteins kind of get leaked out, it will end up in the ground as a fossil, right? We could have, basically what we have is fossil fuel, okay? Fossil fuel. Okay. Now, this putting into the ground of these once living molecules of carbon, this process is called deposition. Okay, that's not the best explanation of that, but there you go. Deposition is when these carbons that were in the macromolecules over time, long periods of time, become fossil fuels in the soil. Okay? Now, I like a good bonfire, right? I don't know if you knew that about me, but I do. So let's say I take some of these branches over here, take some of the roots, make a little bonfire for myself. There's still carbon in there. There's still hydrogen in there. And if I make a bonfire, let's make a fire. Yum. Okay. Should we add some orange too? Why not? It's my video. I can do what I want. Okay. So we make a bonfire. Oxygen is needed for this as well. Okay. We're burning, we're igniting the wood, and we're creating a flame. This process is known as combustion. And this also contributes CO2. Okay? So there are lots of processes that we do on a regular basis, whether it's building bonfires or respiring, or what other things do combustion? Okay? Hopefully you're thinking about a combustion engine, right, in your car. Those take these fossil fuels, right? Gasoline and everything that's coming from the earth, or fossil fuels, we are burning them in our cars, right? We give it a little oxygen, we give it a spark when we turn the key in the ignition, and carbon dioxide comes out of our tailpipe along with some other toxic chemicals. Okay? So those are 5 of the 6. Now, let's make an ocean here. Yeah, let's go with this one. Okay, there's an ocean right next to my bonfire. It's cool. Sometimes this carbon dioxide in the atmosphere ends up mixing with the ocean water. Okay, I don't know how that happened. When that happens, you get something called calcium carbonate that can be used by seashells, by organisms that need seashells for their bodies. Let's say an oyster. Doesn't that look like a good oyster? It sure does. So oysters need calcium carbonate to make their shells, and they can take this from the dissolved carbon dioxide in the ocean water. Okay. Now, at some point, the oyster will meet. The time will come for the oyster to die, and now you have an oyster shell. This is going to break up into several pieces, right? Smaller pieces, and those will become even smaller pieces, right? That's just what happens when stuff breaks down, gets old. Over time, these bits and pieces of calcium carbonate are going to form layers on the bottom of the ocean. Okay, and this forms what we know as limestone. Oh, stone. Okay, limestone. I'm not even going to try to erase that. I'm afraid of what's going to happen. We are so close to the end. This process is called sedimentation. Okay, sediments form on the bottom of the ocean and end up with limestone. We started off as carbon dioxide. It dissolves in the ocean, is used and made into seashells as calcium carbonate, breaks down, forms these layers, sedimentation. Okay, so you see different forms of carbon. You've got carbon dioxide, calcium carbonate, glucose, carbon as the macromolecules, fossil fuels, all sorts of things contain carbon. And this is how carbon cycles through the earth.